Okay, I'm very excited to announce today that we are starting the last topic in calculus. That is integration. That takes care of all three of the things we need to cover: limits, derivatives, and integration. However, you're all fairly bright and you realize that it is November 17th and we're starting the last topic. You can imagine how long this will take. It's fine. It's just a lot of different components, just like we do with derivatives. We learned how to take derivatives, then we applied some theorems, then we did some word problems. The same is true with integration. So today, I think today should be a fairly easy and straightforward lesson. Okay, let's hope. Because it's just an intro. Yes, Molly?
I can't find this inclusion slideshow.
I have not posted it yet. I have dropped the ball. I'm sorry.
Okay.
Let's go. You'll be okay. I understand. That's my fault. I'll take the hit on that one.
No, okay, I'm sorry.
Integration, or taking an integral, is also known as antiderivatives. So you're all smart fellers. What would an antiderivative be? Say again?
I said mean derivative, that was a joke.
Playing off the anti thing. Got it. Okay, really though.
Reverse of the derivative.
It's a reverse of a derivative. Is that you at least? Well done. Okay. It's the opposite of derivative. Just like taking a square root is the opposite of squaring. Subtraction is the opposite of addition, etc., etc. These are kind of inverse functions, but not really. Let's call them inverse processes. They undo each other. Okay? So, that having been said, general solution of differential equations. We're actually going to dabble into differential equations, which is kind of scary because there's an entire course called differential equations that some of you will take in college, which you will enjoy. It's a ton of fun. We'll talk about some notation today. We'll come up with a way to take an antiderivative or figure out what an antiderivative is, and then we'll do some more differential equation stuff. Okay? So, quickly, if I have a function, 3x squared, there is some function that we'll call it capital F, for lack of a better term. There's this function capital F that when I take the derivative of capital F, I get 3x squared. What's that function? X cubed. Anything difficult about that? Is everybody good to go with that? Derivative of x cubed, bring the 3 down, reduce it by 1, we get 3x squared. Okay, so we go from capital F to f of x to f prime of x, which would be what? 6x, and then f double prime of x, which would be 6, and then, where are I at? Triple prime? 0, and then 0, 0, 0, forever and ever and ever. Okay? So now we're going backwards a step, and that is what we commonly refer to as capital F. Does that seem difficult? No, good. And it's not going to get any more difficult. That's about as easy, or that's about as difficult as it's going to be today, hopefully. Okay? So we've got some notation there. When I take the derivative of x cubed, I get 3x squared. You know that already, so we changed the notation to make capital F of x being that x cubed. It's that starting function, going backwards. And that's called an antiderivative. But, here comes the first but, are there any other answers to the question? Give me an example.
So if it was like x cubed plus 6.
Ooh, x cubed plus, is the derivative of x cubed plus 6 equal to 3x squared? So how many answers are there to the question? Infinite. That causes some problems. Actually, it doesn't cause any problems. We just need some terminology. So the terminology is, we're going to call that a family of derivatives. And as Atlas said, if you stick a constant on the end of that function, you could take the derivative and still get 3x squared, and there's an infinite number of constants that you can stick onto that function. Okay? And there are a lot in a family. Initially, we're going to talk about families of antiderivatives as the answer. And we need a way to represent that, because if Molly takes an antiderivative, she may get 3x squared plus 4. If Adrian takes the antiderivative, he may get 3x squared minus pi. Both are correct. How do we represent that? We use something called a constant of integration, capital C. So this eliminates the idea of one person picking -7 and another person picking pi and someone else picking E and somebody else picking 10,431,785. And we just say C. The important thing to remember with C is a constant. It's a number. And when you take the derivative of a number, you get 0 and it goes away. Okay, how are we doing so far? Easy peasy lemon squeezy? No, I'm not going anywhere.
Okay.
I'll give you time. It's cool. Especially since I forgot to post the slideshow and some of you are writing all this up. I'll take a drink. I got this new mask and it's got an extra little string on it,
I was looking at that.
which I haven't figured out what to do with.
Maybe it's like no, it's just maybe it's for when you take it off, you don't lose it. Like those
That's
things
probably
for
true.
glasses.
Yeah.
Take them off.
So like if I take, oh,
Yeah.
oh,
Yeah.
all right.
It looks kind of silly though.
Or I could just cut it off.
You could
Yeah.
do that.
Looks like I have braids,
Can you
doesn't
put
it?
it back on your head again? That was funny. That's cute. I love that.
Great, thanks.
Put a little bow on it.
Let's just, in case it falls off. Okay, so what we will eventually get to is solving problems to figure out what C is, which will need more information. But when we do that, that process is what's called a differential equation. We'll get to that later. Now we're just doing the basics. Okay. So if y prime is 2, what's y? Don't overthink this. 2x. Good. Everybody good? What am I asking? I'm asking what is the function whose derivative is 2, and we would get 2x. That's almost correct. Plus c. Very good. Plus c. We're going to, not we, I don't, but you might forget that plus c a lot. And I'm going to continue to say plus c over and over again until it burns into your brain. It is crucial when you're taking an antiderivative that you include that plus c to represent all the possible answers that you could get. Okay, dokie. Let's get into some notation. We get a new symbol today. Okay, so here's the new notation. That little squiggly thing. Some of you are going to struggle drawing the squiggly thing. And to be honest, after all my years of teaching this class, I have been unable to find out what that thing is called, other than the integration symbol.
So ugly.
Now, as you continue to do problems, you're going to add your own flair to this. Try to keep it under a minimum. I don't want to see this for taking an antiderivative. I also don't want to see that. Okay, try to make it as close to that symbol as possible. And for lack of a better term, we'll just call it the integration symbol. Okay, so that thing that you're taking the antiderivative of is called the integrand. It does not include the dx. You see that little dx hanging out there? That dx is very important and is called the variable of integration. For us, it's not that big of a deal. The reason being, we're studying single variable calculus. So when you take an antiderivative, your variable is always going to match. When you get to multivariable calculus, as many of you will, it becomes very important because you'll have x's and y's all in there. You got to treat it differently. Capital F is the antiderivative, and C is the constant of integration. You killed it when I asked you for the antiderivative of 3x squared. You did a great job when I asked you for the antiderivative of 2. What we haven't done, however, is come up with a general rule. We have a general rule for derivatives. I would love to have a general rule for integrals, so that we're all doing the same thing the same way to get the same answer. Okay? We'll get to that in a second. I forgot to mention the term indefinite integral. Antiderivatives and indefinite integrals are the same thing. It will get a little confusing in a couple weeks when we get to what's called a definite integral, but that's further down the line. Okay, they're the same thing.
Oh, sorry, Bobby, I have to change that sign real quick.
Do what you gotta do, buddy. Where do you wanna put it? Right there?
Yeah, put it right there.
Okay, help yourself.
Thank you.
You're welcome. Okay, so let's suppose I've got this guy. And let's talk about that a little bit, because the order that this thing happens in is very important. So if you look at that initially, it appears that the integral and the derivative are canceling each other out. Does that make sense? You're taking the integral of a derivative, and you end up where you started. Just like if you take the square root of a function squared, you end up back where you started. Are you with me? Okay, now notice there's a plus c on there. Question: did I take the derivative first, then the antiderivative, or did I do the antiderivative and then the derivative? Which one came first? We got also a convoy. Which one did I do first? Derivative. Great. So I took the derivative and then I took the antiderivative. Since I ended with the antiderivative, I need the plus c. Make sense? Yes? Okay, good. Now, what if we change the order? Now I took the antiderivative and then took the derivative. They seem to be the same thing, except you'll notice in the second one, I have no plus c. Why?
Because c is a constant, and if you grab a constant, it becomes 0.
Perfect. Okay, so that's about one of the few conceptual points we have today. The rest is all just mechanical. Does that make sense to everybody? And or do you need a clarification on that? It comes down to what did you do last? If you take the integral last, you have to have a plus c. If you take the derivative last, no plus c. All right, everybody good? Am I going too fast or are we fine? Okay, beautiful. Okay, so we have this function x cubed. I don't necessarily, I do want to know what is the antiderivative of x cubed, but more importantly, I'd like to use this as an example to figure out how to find the antiderivative of a function. Okay, so first of all, what's the antiderivative of x cubed? Let's get an answer first. Make sure you're up with me on that. What function, when you take the derivative of it, equals x cubed?
Thank you. Have a nice day.
See you, Phil.
1/4 x to the 4th.
1/4 x to the 4th. Does that make sense to everybody? We'll take the derivative of it. Let's see. If we take the derivative of 1/4 x to the 4th, bring 4 down. 1/4 times 4 is 1. And Bruce does it. Well done. Okay. Good.
But is that the derivative? How come it just says f of x?
That's the function we're starting with. We want the antiderivative of x cubed, which would be, you're correct, 1/4 x to the 4th. Okay? So we're all good on that, yes? Well, what if the function changes? So what I'd like is a general rule to take the antiderivative of any polynomial. Let's suppose I have x to the 7th. What would the antiderivative of x to the 7th be? 1/8 x to the 8th. So what's the general rule? What are you doing? let's suppose I've got x to the nth, n as in narwhal. What is the antiderivative of x to the narwhal? X to the n, sorry. 1 over narwhal, x to the narwhal?
One above normal.
No, if it's, because I have to cancel out. So 1 to the narwhal. Wait, is the original function narwhal?
The original function, okay, yeah, I get it. F of x is x to the narwhal.
Yeah.
What's the antiderivative of x to the narwhal?
1
Over
over
n
normal
plus
plus
one.
1
Yeah.
over,
Oh,
I mean,
to raise
to
to the
the
n plus one.
normal plus 1.
1 over
N plus 1
narwhal plus 1
Plus
X.
over n to the one.
times.
x
And
raised to the normal plus 1.
Yeah, that's that.
Are you sure?
Yes.
All right, just messing with you. Good. Okay. So we're doing this in reverse order. If I was taking the derivative, I bring the exponent down, reduce it by 1. Done. Now we're taking the exponent, adding 1, and you could say dividing by it, but what I like is multiplying by the reciprocal. Because 1 over n plus 1 is the same thing as the reciprocal of n plus 1. That I think will prove to be a little bit easier, especially, okay, let's do this. Change colors. Let's suppose g of x is x to the 2/3. What's the antiderivative of x to the 2/3? Close.
Sorry.
Say it again.
Oh, I was talking to myself. 5/3 x to the 5/3.
Close. I'll give you this.
Could it be 3?
Good.
3 halves.
Not 3/2. 3/5 x to the 5/3. So, Delaney, where'd you get the 5/3?
3/3 plus 2/3.
Bingo. Added 1 to 2/3. Okay, then remember you have to multiply by the reciprocal of that new exponent. Okay, because now if I take and here's the nice thing about antiderivatives. As you're learning those, by now you're pretty much experts on derivatives. You should just be able to check it by saying, well, if I take the derivative of this guy, bring the 5/3 down, 5/3 times 3/5 is 1, reduces by 1, 2/3. Woo, we're good to go. Good. I'm impressed. Most people wouldn't get there. I have it written out all fancy like, I think, after I erase. Erasing. Whoosh. There it is. Okay. Oh, we forgot the plus C already. Let's not do that again.
Oh my God, you do
Questions? Okay, this is going to be a little bit difficult early on because you're going to want to apply derivative formulas because you've been doing derivative formulas since early September. It's going to take a while to get your brain to start thinking in integral form. Then, later on being January, February area, you're going to be doing integrals and derivatives at the same time, and your brain is just going to run right out of your ear. It's going to kill you. But we'll take baby steps and get you there eventually. Okay. This is really important. That's why it's flashing. Okay? I got some really good news for you. I think you're going to like this. I'm being sincere. There is no product rule, quotient rule, or chain rule for integrals. Okay. Now, hold on. Okay, flashing. Muy importante.
Oh, yeah.
Now, it's important that, in fact, I'm going to make it flash once more. Because what's going to happen is, some of you knuckleheads are going to dive into an integral and apply the product rule to integrals. But don't do that, because there is no product rule, quotient rule, or chain rule for integrals. Okay? Are we good? You're going to remember that, right? In case you don't, there is no product rule, quotient rule, nor chain rule for integrals. Well, how are we going to take the derivative of big complicated functions? I'll show you later. We have something called UDU, which is quite a bit easier, but that's, we got to crawl before we run. Trig functions. I know. Now let's talk about these for a second. Yeah, go ahead and take a picture if you'd like. These you should have known, because we know that the derivative of sine is cosine. We also know that the derivative of cosine is negative sine, so I just moved the minus sign to the other side. So you're saying to yourself, why do we care about the integral of secant squared? Why is that there? Why isn't it just cosine, sine, secant, cosecant, tangent, cotangent? Because we're not ready for that yet. So we're cheating. These 6 things, if you look on the right-hand side of each of those equations, are our 6 basic trig functions. Sine, cosine, tangent, secant, cosecant, cotangent. So we're forcing the issue. Later on, we will talk about what the integral of tangent is, what the integral of secant is, what the integral of cotangent and cosecant are, but we're not ready for that yet. I hate to admit it, but this is note card worthy. You just got to remember this. And I'm going to show you this. I hesitate to do this, but I will explain that. When I was in college, I learned how to remember where the minus sign went. I was not a big fan of memorization. So one of my college professors showed me the following thing. It's incredibly stupid. I realize that. But I seldomly, if ever, get the minus sign wrong. What I'm talking about is what's in the rectangle here. I had trouble, or people have trouble remembering, because now we've done derivatives and integrals, they have trouble remembering where the minus sign goes. Which one gets the minus sign? So it goes something like this. Can I take this thing off the top of my head? Thank you. Here, I'll just hang it on my ears. I'm sure that's much better. I'm taking the derivative of the the integral of the sine function. So I turn the dot in the sine into a big golf ball, and I turn the integral symbol into a golf club. I'm telling you this is incredibly stupid, but if it helps you, great. So when I take the integral, I swing the golf club, and the golf ball travels so fast it's just a blur. Again, I'm not proud of it. But if it helps one student, it was worth it. Don't look at me like that. Now you're saying to yourself, can't I just turn the O and cosine into a golf ball? Yes, don't complicate the process. It's the dot on the sign.
But you can't hit a golf ball without a golf club, so.
If the club is the integral symbol.
Well, that's what I'm saying.
You wouldn't be able to
Cosine.
hit a golf ball if it's sandwiched between a C and an S.
Yeah.
Right.
Because you're on a club.
Thanks, Kay. I'm
You
glad
can make a ball, but you can't hit it.
I'm glad you're here.
Wait. You said you could turn the O and cosine golf ball, but people
Is there nothing to do with the cosecant or cotangent?
No, I have no clever things for that. I'm sorry. Yeah, those are just flashcard
Those are the ones
memorization.
I forget, because I can remember those.
Wherever there's like this sign and it's not in a tangent, it's a sign change.
I'm sorry, what?
Wherever there's a sign but it's not in a tangent, but like you just ignore that because it's tangent, there's a sign change. Because like in all the
true.
cosecants and in the sign, there's a sign change.
Well, I will say that what I do for the other ones is I know that if it begins with a C, you change the sign, but that's screwed up with the cosine and the sine. Notice the cosecant squared, the cosecant, cotangent have minus signs because you see the minus sign there.
Yeah.
You see the line. Yeah, but that's all screwed up with cosine and sine. All right, let's move on. Okay, so the ideas that we applied in derivatives also apply to antiderivatives. So for instance, instead of worrying about this 8, in other words, I'm going to take the antiderivative of 8x cubed dx. Instead of doing that, I could just do this. Take the antiderivative of x cubed and then multiply it by 8. Having said that, please find the antiderivative of 8x cubed plus 7 sine of x.
I went to targeting panel.
That's why he's in this class.
And I'm playing with the hammer.
Yeah, which makes sense.
How do you spell
I'm
it?
playing with the hanger and I'm like bending it and
Which I guess makes sense.
Well, it'll make more sense in the future when we hear about what we're going to do with it.
it's like holiday. It's like holiday. Or Hanukkah.
Okay, so it appears that everybody's good to go, yes? Eric, what's the answer?
2x to the 4th minus 7 cosine x plus c.
Say that again. 2x to the 4th.
Minus 7 cosine x plus c.
Well done. Good. Okay, so to get some notation squared away, if you wanted to write this as a problem without the verbiage, you would put a squiggly symbol there and you'd have a dx over there. As soon as you take the antiderivative, the squiggly thing goes away. By the way, Matthew just informed me he looked it up on Wikipedia and it's called the summa.
Yeah.
I like squiggly thing better. Problems? Good. It's not going to get much more difficult than that. What, ever? No, today. Question, Lily.
What's like the final notation?
There is none. That's it. Done.
Then what's the low?
The squiggly thing tells you take the antiderivative of this thing.
Oh.
I thought that was how you write it.
No. That's how you write the problem.
Oh, so
Again, so clarification. Squiggly thing of x cubed dx is equal to 1/4 x to the 4th plus c. Take the antiderivative of this thing with the variable x. There's your answer. Don't forget your constant of integration, so you get the family of antiderivatives. Okay, good. So there's one other thing that we want to talk about, and that is, can I go from a family of answers to only one possible answer? Okay. So think about having a function like x. I take the antiderivative of x and I get x would be x squared. Or sorry, 1/2 x squared. A parabola. And then sticking a plus c on the end, all it does is take that parabola and move it up or down. So we get an infinite number of parabolas stacked up on top of each other. Instead of an infinite number of parabolas, I want only one of them. And in order to know which one I want, you have to have some other information. And that would be, which one do you want? Where is it located? It looks like this. Blah, 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 blah. Get that already. Okay. Yeah, what?
Wait, are we supposed to
Really?
write parentheses
You
on
said
the
it
whole
wasn't
thing
gonna
and
get
then
that far.
That's not hard.
Wait, so
Hey, I was gonna skip this. Do we need to talk about this?
no.
Right? This is 12x to the fourth minus 5x to the 1/3 minus plus x to the negative 5 dx. You can do that, can't you?
Wait, do we need to put parentheses around it before we put the dx?
Yeah, if you want to be fancies in your pantsies, you probably should, but it's not a deal breaker.
Alright, relax.
So I was going to skip this because you guys were doing very well. Is that okay to skip, or do you want to?
Yeah, it's good.
It's okay to skip. All right, good. I want to get into something more interesting, and that would be doing a differential equation. Differential equation means, oh, look, I've got this family of antiderivatives. I don't want all of them. I want just one of them.
So you're gonna differentiate.
So we get something like this. Okay? So I have a function, capital F prime. It equals 1 over x squared. Let's start by taking the antiderivative of that. By the way, let's start by doing this. Okay? So what is this? What's the antiderivative of x to the negative 2?
Negative x to the negative.
Perfect. Negative x, not perfect, I lied. Okay, you forgot something.
Plus c.
Plus c. Good. Okay. And this is equal to f of x. Capital F of x, doesn't matter what we call it, but it's still f of x. Okay, so we're good to go, and then this little bugger pops up. That information tells me which of the infinite number of functions we want to choose. The stuff that's circled, what's x? What's y? 0. So we plug and chug. 0 equals negative 1 raised to the negative 1 power plus c. What's c equal? I didn't think it would be that difficult. Yes, it's 1. It's 1, right? We're good. 1.
Oh.
So therefore, our final answer is x to the negative 1 plus 1. That's f of x. So again, we went from a family of antiderivatives down to one particular solution. It's like going to a family reunion and finding the weird cousin. Every family's got a weird cousin, right?
Yeah.
However, there is a saying too that if you can't find the weird cousin, you're the weird cousin.
My weird cousin is a
I'm just saying.
He's not vegan anymore.
He's really weird.
She's like, what about that?
Are you talking about your weird cousins?
I was just saying, I know I'm not doing it.
Oh, well then you're good to go. Yeah. Does anybody think they're the weird cousin?
There's a chance I might be, and I kind of.
What's that?
Well, like in my close family, it might be me. In the larger picture, it's my cousin Mike who does magic tricks constantly.
I mean, there's nothing wrong with magic, assuming you're doing it at the right time. At your grandfather's funeral would not be a good time for magic tricks.
It's all the time.
In the line at Mariano's would not be a good time.
That would be a great time for magic tricks.
Is this your card? Huh.
I know. I'm sorry. I'm on the other side of the
I didn't hear you. What's that? I have a good friend who's a mortician, and it creeps me out. He's like, anytime you want to come in, I'll show you the like, no.
I took a school class.
He doesn't talk.
Like all the time?
I took a
My friend's pretty normal, except he's a mortician. Your friend's not normal and a mortician.
I took a class.
And he's also like the one.
You're meant to be that.
Okay, your turn. What's your motive? Solve the differential equation, please. Is he really tall and skinny too?
Yeah.
No.
He sits just by himself in a chair.
Is he gone?
He also doesn't eat normal food.
Is he
He's really, I think he's also vegan. He's really weird.
You know he's like talking to dead bodies,
His
right?
name's Cody, isn't that also?
Oh, that's the deal breaker right there.
Cody
Oh,
the
yeah.
I was gonna cut him some grief, but knowing he's named Cody, he's done.
He's really weird. Nobody really talks to him. It's really sad. You don't talk to Cody the Mortician. No, I'm scared of him. Oh, I mean, I would be too. He also has glasses.
Well, you
You
know,
know those like
mortician-
carry glasses? That's the type of glasses he wears.
You know the morticians don't kill people, right? They just embalm them.
But like, I feel like he could.
Oh, so you're thinking he's a serial killer
He
slash
like might be a
mortician.
serial killer. He's like far. He's like probably my second cousin though, so he's not like.
Wait, I'm stuck on 4x. What is 9x? 3x. Oh, this is too thinking. Like, I can't think backwards.
Especially since it's like not an equation you just plug it in. It's like theorems.
No, I can't either.
Like,
Like, this is easy for most people, but for me, this isn't difficult. What is it, just x to the, oh, wait.
2x squared.
Yeah.
you plug it in.
Oh. I don't remember.
I thought you said that it'll be secret sauce.
I
It doesn't make any sense whatsoever. I'm like, what are you?
Oh, I did it backwards.
I mean, unless of course you learn about awesome sauce.
We're reversing it.
Good, so rewrite the whole thing. That's what you got for C. Rewrite the whole
Oh,
thing.
no, that's fine, that's fine.
3.
Plug in 1.
Wait, I'm sorry.
Okay.
We're gonna do 5 equals and then plug in. Plug in 1 for all the x's, right? Yeah.
I'm not sure at all.
7 equals 2.
That's what I have.
I mean, I do things right. I never do things right.
Yeah, that is right. I got I literally can't think of it. If I get like a S R U O N M L. What are you talking about? You really could do that thing. G F. What are you talking about? What are you talking about? I said the whole alphabet backwards. You could have said anything.
Why was there K in there? Did you say K? Okay, I think I did it right.
I know you did it right. Okay, so Hafiz has been kind enough to solve the problem for us. Do you want to talk us through it?
Yeah, so,
Okay, give me my pen back. Okay. Next thing you know, you walk out of there. All right. Shh.
so you start off by obviously taking the antiderivative, and that comes out to be 3x cubed plus 2x squared minus 7x plus c. And then
Okay, stop for a second.
Uh-huh.
This popped up with a couple people. What's the antiderivative of a constant? You add x to it, correct? Because you're going from constant to a line, and then a line to a quadratic, quadratic to cubic, et cetera, et cetera, et cetera. So, okay, back to you. Sorry for the interruption.
And then you set that equal to 5, and then you plug in 1, and you get c equals 7, and then you write the function with knowing that c equals 7.
Perfect. Let's give it up, huh? Woo! Nicely done. Nicely done. Okay. Oh wait, I skipped that one. Okay, so, notice what I did here. We're gonna end on a high note. I'm giving you f double prime. What's the antiderivative of f double prime? F prime. What's the antiderivative of f prime? F. So you're working backwards to get to f. Go. 2 times.
2 times.
2 times.
What? I didn't even 1 time. You just did about this class. That's actually so. What if I like quit?
I used to. Yeah, I'm not sure.
Actually,
I do. I'm just holding on to if I finish this class.
Actually, I do like math. I just don't like word problems. I'm going to retake algebra.
I'll throw it out of class.
I love geometry. I thought I was taking reading classes, like higher prescription than I already have. Because like when I look down, I can't see.
Well, that's what I'm just saying right now.
Plug in f prime with 0.
You need this help.
My brain hurts.
Everything is bad pretty much, and I just like.
Is it negative 3 cosine x?
Cosine equals sine.
Yeah. Plus 5 sine x? Yeah. Plus c? Oh my god. We're doing it again? Yeah, you have to find a c for that and then take another one.
Oh my gosh, you have to find.
Wait, you just need the same thing? Wait, no, you have to solve for c as a prime.
The first part of the problem?
And then take the antiderivative. Then
Do it in
and then
stages.
solve for c.
So figure out, you know what f prime is?
Wait, is it just, it's like a
So figure out what f prime is first with a c, then use that to solve for that c. Then take the antiderivative again and use that to solve for the other c.
So then
And then plug in y over 2.
Wait, so when does the c show up? That's my
so there's 2 yeah. Then c and then take another derivative and find another c. First section. No.
Yes,
Adding 11. Yeah. Okay.
You take the derivative.
You take the antiderivative.
-3 sine? Or is it positive?
I think it's negative. Yeah,
-5 cosine? Just 5.
No, minus 5.
Add plus underneath subtract.
5x?
Then plus 8.
Slave x.
Yeah.
What did you get for your first c value?
I moved over
Hold, please.
3. So 3 plus
Hold, please.
5.
Oh.
Get C plus C and plus C.
Oh, right.
I don't know what that means.
Same.
Oh, okay, yes, okay. You're scaring me. Keep going.
This is where.
And then we plug in minus 5. Yeah, okay.
What is it?
I'm just gonna write it down and then I'm like, what is sine of
5 over 2. Okay, where's pi 0?
0?
I choose this one, right? Yeah, so the sine would be 0.
Well, they got- I don't know.
Cosine would be
They
1.
got the same
The cosine would be 0.
So you're either all wrong or all right.
Yes, that feels right.
No, you're right.
So 0 or 1.
If pi equals
Negative.
-3
Yep.
plus 5 pi over 2.
Yeah.
That is
Plus C.
nasty.
Stop everything. Emily's upset. She's annoyed.
I mean,
What can we do to make it better? I don't really care.
wait, negative 3 times x is
Negative 7 pi over 2 equals negative 5 pi over this is so many pi's. Put 8 minus pi minus 5 pi equals c. But pi. Do I have to make this additional? I don't want to be a That's what we're taking because I subtracted 5 pi over 2. What's pi minus 5? Here, I'll write it out because
I know I've done you a disservice by asking you to do a double differential equation while also throwing in trig. I get that.
I made that
But
the same.
it's time to come off the porch and run with the big dogs.
Oh, that makes sense. So negative 7 pi over 2 minus 7 is
Emily, what's the antiderivative of f double? What's the antiderivative of f double prime? What was the last bit? Oh, not yet. Plus c. Good. We'll get there. Okay. Now, in a problem like this where you have multiple c terms, if you want to get fancies in your pansies, you could, one option would be to call this c sub 1. And then call the other one c sub 2. Or you could call that c and call the other one d. Or you could just both call them c, I don't care. So I'm assuming then you plug 0 in for x, 2 in for f prime of x, and solve to get c equal 5. Are we all good with c being equal to 5 here? Okay. So f prime of x is equal to negative 3 cosine of x plus 5 sine of x plus 5. Changing colors. Keep going, Emily. What's f of x? Good. So then you plug in pi over 2. Again, refreshing yourself on the unit circle. The sine of pi over 2 is 1. The cosine of pi over 2 is 0. Negative pi is equal to negative 3 times the sine of pi over 2 minus 5 times the cosine of pi over 2 plus 5 times the pi over 2 plus c. Emily, after doing all the work, which I'm too lazy to do, what's the second c turn out to be?
Negative 7 pi over 2 plus 3.
Can somebody confirm?
Yeah.
Say it again. Negative 7 pi over 2 plus 3. Whoops, not c, plus 3. That? Awesome. So then take that value, plug it back in up here for c, and sure enough, we've got f of x. Well done. Let's give it up for Emily.
When we rewrite that c, then we'll be different parentheses because that's a new value for c, or does it not
Doesn't
matter?
matter. Eric, question.
Where did the 5 come from again?
Emily, where's the 5 come from again?
You plug in.
There's one right behind you.
You plug in 0 for f prime of x, and then plus c equals 2. You solve for c.
Did you follow that? Use the first chunk of information. Plug 0 in for x here and here. Plug 2 in for f prime of x. Solve for c. Alice.
How do you get the plus 3 in at the end?
This is 1. So we get, I'm going to squeeze it in here because I'm running out of space. That's negative 3. This is 0, so it disappears. This is 5 pi over 2 plus c. And then this is equal to negative pi. Okay? So when you move the negative 3 to the other side, it becomes positive. Alrighty? Now, am I wrong in assuming that's not too bad, right? This is kind of bad, but it's still doable because we're just doing a basic antiderivative rule. We're good? Excellent. Last thing I have for you is the public service announcement. So please, where's the dog? I have a dog one that's coming later. A puppy dies every time you make another silly math mistake. So,
No pressure.
yeah, well, don't do it
Dies every time.
unless you don't like kittens.
Oh my gosh. And you want to hear a really sad fact?
Hold on. Yeah, the last fact you told us was a blatant lie, Molly.
It's true.
It is. That's what you said about the last one also.